This is like trying to contain a star, right? You can't use a physical bottle to do that. So you use fields. And what we do is we use magnetic fields, and we exploit the fact that charged particles will follow magnetic field lines. So the whole concept of a tokamak is to create a magnetic field configuration that can contain this super hot plasma long enough for fusion reactions to occur within this plasma. So this is the inside of the device, and actually the plasma is so hot that you actually can't see it in the visible spectrum. And what you're seeing in this picture right here, all these light bits are when the plasma actually is touching the wall slightly, and when it touches the wall, which is a lot colder than the plasma, it cools down, and it cools down enough that it emits light that you can see in the visible spectrum. So actually there is a plasma going around here, you just can't see it.
Cool, let's check it out.
So we gotta grab some hard hats.
This is CMOD here, right?
This is CMOD right here. Behind that is the actual tokamak. Behind those shields is the actual tokamak itself. And so all the stuff coming into it, there's power for the magnets, there's power for the heating. So we use microwaves and radio waves to actually heat the plasma up inside of the tokamak. There's also, a lot of this stuff is diagnostic. So because this is primarily an experiment, people want to measure everything about this plasma while we're generating it. So people measure the density and the temperature of the plasma, the pressure of the plasma, things like that.
There's a big push in the government right now toward renewable energy, clean energy. People might ask, well, we've already got solar, we've got wind, we've got hydro, all clean energies, renewable energies. Why do you think we need fusion reaction?
Well, I think one of the big advantages of fusion is that it can be baseload powered. So this is something that once you turn one of these reactors on, it operates it puts out power the same way as a conventional coal plant or even a conventional nuclear fission plant, where it's always on, like night and day. So having baseload power is really important. So we can go up to the top and take a better look. Right now we're kind of taking a look, top view of the tokamak of CMOD. We have what are called klystrons. They're basically, I was telling you about heating the plasma before. And so this kind of bank of klystrons here feeds in the microwaves that we use to get the plasma into the really hot state that we need it to get to in order to make fusion reactions occur.
You mentioned that you measure it in Teslas, did you say?
Yeah, the magnetic field is measured in Tesla.
Okay, how many Teslas would it be?
So CMOD's maximum field is around 8 Tesla.
Okay, that's for the geeks out there that understand what a Tesla is. All right.
So that's about twice the field of a medical MRI.
Wow.
So it's pretty big.
That is very cool. This is not a working prototype per se, but what's the end game? What's the purpose of this?
The purpose of this is to basically inform the next device that we build. We want to characterize conditions that lead to good plasmas, high performance plasmas. So at CMOD, at MIT, the thing that makes this tokamak kind of unique is that we can achieve very high fields inside the tokamak. We study high magnetic field confinement. So we do a lot of experiments to characterize plasmas inside of a high magnetic field environment. And then the next device that we build, we can use the data that we've collected on CMOD to inform the design of the next kind of device. There's a really big team that works here, and that's, I think, really our greatest asset.
You've got like 50 PhDs training.
Yeah, exactly. Yeah. And there's undergrads that actually work in the lab too. So it's a very large lab, very talented group of people. And so we're hoping that we can build another device here in the future and continue studying fusion plasmas.
And eventually create that arc reactor that we're talking about.
The ultimate goal will be creating something like the arc reactor that actually produces power.
Right. Hey, thank you so much for
taking
me
my pleasure.
through. I really appreciate it.
Definitely.